Everyone, thanks for being here today. Yeah, as I'm sure everyone else is feeling, it's kind of weird to be back at a conference and speaking in person, so really appreciate you making the time to be here today. My name is Joe, and I'm going to be talking about Jetpack Compose and accessibility. So yeah, let's get started. So before we get started on the Compose side of things, I want to take a kind of step back from technology and technical content. So I think unintentionally, it's easy for us to kind of be isolated from others around us. We get caught up in our day-to-day lives, we do our things our way, and we kind of forget how other people might experience things and how other people might need to do things. For example, how you made your way to this conference, maybe you flew, maybe you walked, maybe you got a train or public transport. I think we forget about these things and we don't know how other people are experiencing those situations. Being in this bubble, it may be a surprise to know that 15% of the world's population have some form of disability. That's equal to about 1 billion people. So whilst this is kind of vague, seeing as there are so many disabilities that exist in the world, this is actually quite a high number. And a lot of disabilities can be age-linked. So as the years go by, we're bound to see this number increase, and with life expectations increasing as well, maybe that will increase with it also. And that statistic is validated by the fact as well that only 17% of people in the UK who have disability were actually born with them. So the other 83% of that, which is about 11 million people in the UK, have developed those disabilities at some point further in their life. I'm not trying to scaremonger you here, but that is just a statistic that I've able to find during some research. So when it comes to these disabilities that people experience, it can be important to bear in mind that there's actually a lot of crossover in, so if we're building things to be accessible, we may build something that helps someone who may be blind, and that may also help someone else who maybe has a cognitive disability. So with that in mind, what can we do about this when we're building apps with Jetpack Compose? So we'll come on to the practical side of things shortly, but first we're going to take a look at how things are working underneath the hood. So the key concept here when we come to accessibility in Jetpack Compose are semantics. We're going to be hearing a lot about semantics over the coming slides, so it's important to understand what they actually are. When I first started looking at Jetpack Compose, I had no idea what semantics were, and I kept seeing it being used. So when working with a view-based system in Android, if you have done so far, our views are clearly defined. We have some view that occupies some space on the screen, along with the various properties that it holds. When it comes to composables, our UI is emitted into the UI hierarchy, and at that point, we rely on semantics for these services to be able to understand what is happening within our UI on screen. So when it comes to the use of these composables to build apps with Jetpack Compose, composition provides a description for components within our user interface. These composables are then run to produce a representation of our UI. So we can view this representation as a tree-like structure that describes how our user interface is going to be drawn. However, this isn't the only tree representation that exists. Alongside the description of our composition, there is also a tree that represents the semantic meaning of composables. So these are two very different concepts. The composition describes how our UI is going to be composed, as in how it's going to be drawn on screen, whereas the semantics tree is responsible for describing the semantic meaning of these composables, giving meaning to each component that is being represented. But why does that even matter? So when it comes to accessibility services and also the testing framework in Jetpack Compose, knowing how our composables are being drawn is not too useful to these. Accessibility services need to describe the components to users. So describing how the composable is being drawn is not going to provide enough information to aid the user of our apps. So for testing frameworks, again, these will not be enough information to be able to interact with our UI via the Jetpack Compose testing APIs. Instead, these services need to know more specific details about these composables. And this could be a textual value that is being displayed to the user, or some form of description that describes a visual component within our composable. The way these services can look at the description of our composables and portray this effectively to the user, as well as providing a way for developers to perform assertions and interactions within specific components within tests. The good news is that in a lot of cases, semantic meaning will be automatically applied for us when we are using certain kinds of composables. So for example, If we use a text composable to display some text to the user, this will be represented by the text semantic property. This text becomes how this composable is also going to be described via semantics. That means that when a screen reader is focused on this composable, this description will be read to the user to describe that composable. In a similar fashion, from the Compose testing framework, we can then use this description to locate a node inside our composition tree, and then once the node has been located, we can perform assertions on it. Without this description, it would reduce the usability of our app when accessibility features are enabled. It would also be difficult for us to locate these within our tests. So while some composables will populate these for you, in some cases you actually need to manually provide your own descriptions. For example, in the case of a visual composable, such as an icon or image, if the visual representation of these adds some kind of context that is helpful for the user, this aids the experience of our app. The screen reader will not be able to describe these elements without that description. The same goes for custom composables and layouts, or lower-level drawing on the canvas. If you do not provide descriptions that will be used to populate the semantics tree, then the accessibility services will not be able to describe those components to our users. And also, from the testing side of things, you'll also experience difficulty when trying to automate the testing of these components. So for a lot of composables, I mentioned that semantics are automatically inferred from our composable definitions. So if we have a composable that has some text, that text will be used for the text semantics. However, in a lot of places, there are composables that will not have sufficient semantics to describe elements to users, as well as aid the experience. So as well as there being opportunities to build on the default semantics that are provided, we can actually modify the semantics to provide an even better experience than what is already provided. So just because some things are automatically added, it doesn't mean we have to default to that and we can't improve on it. And this is where we come in as a developer. These are the points which we can intervene to improve the experience of our apps. So now that we have some understanding of how things are working under the hood, we can move on to learning about some of the approaches that we can take to make our composables accessible to users. We'll work through a collection of examples where accessibility can be hindered, allowing us to see how TalkBack operates, which is interesting if we haven't used it before, as well as how we can solve these issues when it comes to Compose. So the first thing I want to take a look at are composable touch targets. We need to ensure that any composables that are interactable by users are big enough have big enough touch areas. So I'm sure we've all interacted with a UI component that has too small of a touch area, and you can just sense it when you've tried to hit it, and you're sure you've hit it, but it hasn't interacted with it. This helps ensure, having these touch areas helps ensure that doesn't happen, and it also makes our apps more accessible. When I first started looking into semantics and accessibility in Compose, this was actually something I overlooked because it's something we can achieve with just using modifiers in Compose. We don't have to touch the semantics themselves. So let's take a look at this composable example. We have an icon, and at the end we have applied the click modifier so that we can listen to some click events on that icon. I don't know what this audio is going to be like on this speaker, but let's try it. It's not going to work. There's no audio. Anyway, cool. So what we can see there from the still video is that the touch target on that composable is small. That's less than essentially what it needs to be. This only wraps the size of our icon, and our icon does not meet the minimum size requirements for it to be accessible, which is 48 dp. So what we can do here is actually utilize sizing modifiers to ensure that our clickable composable has enough spacing to be accessible. So we can use minimum size modifiers or static size modifiers to adhere to this, depending on the content you're displaying. We can also mix this up with padding to ensure that the size is made up to what it needs to be. With this in place, we can see now that our composable has an increased touch area, reducing the friction that a user could encounter when trying to interact with that. So while this works, there are actually some ways in which this can be achieved with much less effort and needing to play around with modifiers. So in the case of our icon, we can actually utilize the icon button composable, which is from the Material Compose APIs. This composable takes a click listener as well as some content to be composed within its body. Being a button, this composable is designed for user interaction. So the accessibility requirements have already been taken into account by the material team who have made these components. This means that we won't need to apply any custom sizing or any padding in order to meet accessibility requirements. And we can see here that this gives us exactly the same result as we saw a couple of slides back, and the touch target is a big enough area to be accessible. So to recap on these touch targets, we need to ensure that they meet a minimum size of 48 dp to be accessible to all users. And remember, you can use the sizing and padding modifiers to achieve this if you need to. While that is possible, though, it's important to use existing implementations where they are available, such as composables that are provided through the material APIs. This avoids us having to recreate the wheel and then modify things that already exist. Another example alongside the icon and the icon button is also maybe the text and text button composables. If you're adding some text which is clickable, use the text button composable because it already does what we need it to do, and it will be accessible. So when possible, I'm sure we've all faced this at some point, is avoid sacrificing touchable areas from design requirements. Maybe you've got designs and touch areas are really small. This gives you an opportunity to pass on feedback to the design team and also educate about these requirements of accessibility. And maybe it seems like an obvious one, but reduce overriding the default touch targets and paddings and sizings that are provided by the material components, because they're doing the job of being accessible, and if we start overriding things to be less, then they're not going to be accessible. Cool. So when UI components are touched or interacted with, or even navigated to, when talkback is enabled, those click events won't be triggered right away. Instead, those composables will come into focus for the accessibility services. So when this happens, some composables rely on descriptions to have their meaning portrayed to users, and it is our responsibility to provide that meaning. So let's say we have this composable, an icon. This could be an image we load from a URL or some local resource, but no matter the source, it is a visual element. These composables all require a content description. This argument here is a nullable argument, but you do have to provide some form of value. So let's see how talkback behaves when we set this as null. We won't see how it behaves. And we have to click play. Oh. Damn, that's not cool. Okay. It's connected to the Wi-Fi. Okay. 1 second. Cool. So we don't have videos, apparently, but we can try and work around that. So, if I remember correctly, when you don't have the content description on, which we would have seen here, the composable would be focused, and there would be no description read out to the user. So if we had a close icon, that would be focused in talkback, but the user would not be described what that component is. So the user would, they'll be a bit confused, like, what is that composable for? What happens if I click it? Should I click it to find out? Is this going to delete something? Is this going to do a terminative action? So what we can do here is we can provide content descriptions to help describe the purpose of those composables. So we have a string in our resources. We get this string using the string resource function. And then talkback, which we won't be able to see here, will read out that content description to our users, and we'll be able to have that described to us, and our user would know what that composable is for. So we could say, in the description, it could be closed screen or closed settings screen, and the user would be able to know what that icon means. Cool. So we might also be working with composables that do not have content description arguments. In these cases, we can actually use the semantics modifier to manually set a content description for a composable. This will be useful in cases where you're doing some form of custom drawing, such as using the canvas, and you need to portray some meaning to the user for what is being composed. So if there's a content description argument available, use it. But if you need to provide a description, use the semantics modifier to do that instead. Cool. So when it comes to these content descriptions, use them to provide meaningful descriptions for composables, allowing accessibility services to communicate those to users. And remember, it's okay to mark content descriptions as null if what you're composing does not provide any meaning to the user, such as something that's for decorative purposes only. In a lot of cases, we are required to provide some form of value for content descriptions, even if it is just null. It's important not to default just to providing null and being one of those things that we come back to do later. I have memories of using the image view in Android and turning off the lint error for it. I think we've all probably done that at some point. And I think with Compose that can be easy to do. So take a moment to think about it, and if you can add value to it, then do so. At the same time, remember, not everything requires a description. If it doesn't need a description, mark it as null. Cool. So alongside content being described, there are further types of descriptions that we can provide in Jetpack Compose. So for composables that are clickable, we can provide what is known as a click label. This is not visible within the UI, but will be communicated via talkback when a composable is in focus that can be clicked. So when implementing a clickable modifier in Jetpack Compose, we're likely going to see something that might look like this. We have some composable that we add the clickable modifier. When it comes to talkback, this would be communicated to the user that the item can be clicked, but they wouldn't know what the click does. If I click it, it will say click action, and the user won't know what that clicking at does, so it could do anything. If there's not enough context there, the user doesn't know what that action is going to do. So what we can do instead is we can provide what is known as an on-click label, which will be used to communicate to the user what that click action does. So this takes a string, and we can provide it in the same way that we would as the content description, and then this would then be portrayed to the user. If they're, say, for example, they have an article card on focus on screen, when the composable is focused, it would say, instead of click action, it would say open item 1 article. And that gives the user a lot more context as to what that click action is going to do. And again, that reduces friction there in that flow. Really sorry we don't have the videos. I was really looking forward to showing everyone talkback, but I'll put the slides online afterwards if you want to watch them. So just to recap on click labels, we can see that we can use click labels to provide interaction descriptions to users for the composable that has an action available. Now, click actions and content descriptions do serve a different purpose. Content descriptions describe the content, click labels describe the action. In a lot of cases, these may be read out together, so be sure that they complement one another and they're not just repetitions of the same content. Don't rely on content descriptions for action descriptions. The click labels are there for a purpose, and users are expecting those descriptions on the click events, so use the semantics, what they're designed for. And yeah, that's kind of related to the first point. Same goes for modifying any other kind of semantic values. If we're describing a click action, use the on-click label within the clickable modifier. Cool. Talking of other semantics, we have text semantics as well. So this is a good segue into this point. So while click labels are used to describe the actions that can be performed through a click event, the text semantic allows us to control the text that is used to describe a composable. So let's take an example here. Very small in the corner of the screen. We have a text composable that is displaying some text to a user. So in a lot of cases, we won't really need to modify the text semantics, but there are going to be scenarios like this, for example. So here we have the P/M abbreviation, I think that's what you call them. But this would be communicated by talkback. You know, we might read that in our heads and be like, oh, that means per month. Talkback, when I had the video, actually reads this as per meter, and that doesn't make any sense unless obviously you're selling something that's £60 per meter. But in the app that I was building, it's £60 per month. That could be confusing to the user. And when it's read via talkback, you might want to read something different. So in these cases, we can use a text semantic property. And this is not what is used to describe the content, but it is actually the property that the accessibility service will provide as a representation of that content. So what we can do here is provide a value that will be used to override the semantic value for this, meaning that this new text property will be read out to describe the actual content of the content. This won't make any difference visually. We'd still see that £60 P/M on screen, but when that is read out by the accessibility services, we'll hear the annotated string that we provided there. Cool, so from this example, we can see we can use text semantics to improve the representation of text that is composed into our UI. We're essentially changing the spoken representation of that composable without modifying how it is displayed on screen. And yeah, because we have this text semantic, it's important to override it where applicable and not use other semantic properties to provide an alternative semantic value. Overriding the text semantic will replace the existing semantic value, so we'll avoid any values being represented multiple times via talkback. Otherwise, you start hearing duplicated speech coming from the services. So on that note also, the text semantics are not something that I personally don't think it's something that I'm going to be modifying too much unless it's special cases where you need to. If it feels like you need to do that and it's beneficial, do so. But I don't think it might be a common thing, but personally I haven't found too much use for it just yet. So with the examples of these semantics values, we've been able to see how talkback will be navigated through the different composables in our hierarchy. You may be thinking, though, that seems like a lot of navigation when we're moving through talkback and every individual component is focused. And what we can do here is utilize something called merging descendants. So let's take a look at another example. The content here isn't exactly too relevant, but let's imagine we have multiple composable children being composed on screen, and when it comes to talkback, every single one of these childs would be focused and read out. So the user would have to navigate to that first text, to the next text, and to the next text. And if this is a list of these columns, you can see that that would get could be very tiresome, and it's a lot of things to navigate through. Instead, we can utilize merge descendants, and this is actually a very minimal change that is required. And this will basically take the children the semantics of that composable and compress them into a single semantic value. So this will default to false. So if you don't provide it, it won't do that. But if you set merge descendants as true, the descendants of that composable will be merged into a single description. So rather than the user having to focus on each text for each item, that item will be focused on as a single entity and communicated to the user in that way. It's important to note, though, that that might not be applicable for everything that you're building, so don't default to just doing this, because sometimes it might make sense to navigate through each thing individually. So yeah, we've seen here how we can use this flag to group related content together into a single semantic tree. It makes our UI much easier to navigate, especially if we've got lists of content. However, navigation should not be a sole reason for simplifying things in this way. If stuff is related, that's great, but if it doesn't make sense to merge those semantics, then we shouldn't do it, because it could just be more of a hindrance to the user than we plan to be. Alongside these semantic modifications, we can also provide further descriptions, one which is specifically used to describe the state of a composable. So for components that have dynamic state that can be controlled by the users, this allows us to add clarity to the state of the component and describe what the state is currently, rather than relying on the visual representation of, say, a switch or a checkbox. So let's take an example of this in the form of a toggleable composable. We have a custom switch composable that can be toggled between on and off. You can see this being manipulated here by the enable flag. So when this is communicated by talkback, the switch will be focused, and it will just read on, off, and there's no context there. What's being turned on? What's being turned off? The user will have to read the labels, and we're adding a bit of friction there and navigating back and forth between different components. But there are things that we can do here to add clarity. So what we can do here is we can utilize this state description semantic to add some meaning to this current state of our switch. So here in my composable, I'm now building a string resource based on the current enabled flag, and then adding that as a state description. So for example, if I had a row here that was enable notifications, instead of the switch just reading out to the user off on, I could say notifications enabled, notifications disabled, and that gives a lot more context to the user via the talkback services. Cool, so we've seen here we can use state descriptions to improve the state representation of content that is being composed, allowing our users to clearly understand the state of a component on screen. And with that said, state descriptions should only be used for what they're used for. We shouldn't use this to instruct the user on the action or any other possible actions that could be triggered, because there's already other semantics that are used for that. If you can improve the description of the state of a toggleable component, then utilize the state description to do so. So on the topic of state descriptions, there's actually stuff we can do to improve the accessibility of the components which use those pieces of state. So things such as checkboxes, radio buttons, and switches. What we can see here is a simple row which has a label followed by a switch. So I'll show the text, and I'll show the switch next to it. I see this in a lot of apps, actually, where here you can only click the switch, and only the switch will toggle. And in so many apps, you try and click the row. I do this by default, and nothing happens, and I have to click the switch. So this isn't just in terms of like people who are using talkback, but also in general, it's just a nice thing to do. Here, yeah, like I said, you can only click the switch. And on talkback, this means that also the label and the switch will be individually focused. So if someone is using talkback, they'll have to navigate through each label and then navigate to the switch to do so. So what we can actually do here is we can improve things by lifting out that toggleable state from our switch up to the parent container. So here we saw this toggleable modifier on the previous slide, and what this does is makes our row essentially like a custom toggle component, and our row is now what is managing that switch state. So our switch still represents the state, the current enabled flag, it's just not handling the check change state, and now our row is doing that. This means that if I'm not using talkback, I can click on the whole row and the switch will toggle on and off. Otherwise, if I'm using talkback, each whole row will be navigated to individually, and we can control that in the same way as if we weren't using talkback. So this is a really nice thing, and I really like it when apps do this. So yeah, we can really simplify the experience if we take the toggleable state and lift it up to the parent container, not only to simplify navigation, but also just make it a nicer experience. Setting the role semantic is something that is automatically done for composables like switch and radio button and so on. If we're lifting things out and using the toggleable modifier, do remember to set the role for the composable. So, okay, that's not going to work. But there's a role semantic, and if we set the role to switch, checkbox, the accessibility services use this. So if you are using custom toggleables, make sure you set the role as well. Cool. So when it comes to these kind of interactions with components, executing a single action is not a complicated thing to communicate to the user. However, there are cases in our UI where there may be multiple actions that the user can execute, or those actions aren't clearly represented within our UI. In these cases, the accessibility APIs provide us with what are known as accessibility actions. So let's take an example. We have a list of items, each represented by a clickable column. Clicking the column launches a screen to read more items about the email. But there's also an icon that is used to delete the email. When it comes to talkback, the user will have to navigate through each card, then to each delete icon, and again, each item that is in there. If there's multiple actions, the user will have to navigate through each of those. And we may even have a user interface that allows you to swipe the card away and reveal more actions underneath the card, which isn't a super accessible UI as it is. So this is something that would have been really nice to have the videos for, but yes, I hope you can picture what that would look like and having to move through each item to execute an action. So what we can actually do is we can use what are known as accessibility actions. These allow us to provide access to the available actions for an item with greatly reduced friction and actually in a native fashion that users who are using Talkback will be used to. So here what we've done is we just defined that there are custom actions available on our items, and we add a custom accessibility action for each action that exists. And again, can't show the video, but what would happen here is that I think it's a free finger tap on the item, and you'll be able to navigate to the actions that are available for that item, and users use this in apps already. So providing these actions in a native way for the accessibility services can really help to improve the experience there. Again, no video. Cool, so yeah, if you're creating lists and items that have actions available on the cards, use the accessibility actions APIs to provide those actions to the users who are using Talkback. But yeah, just because we're providing these actions, it doesn't always mean that we should disregard the concerns for accessibility for the components that are displayed on those cards. So if we have a delete icon and you want to provide that through an action, that's great, but still be sure to provide the content descriptions and so on for the items that are on those cards. Cool. So on the topic of reducing navigation through cards and items to execute actions, there's actually a feature of Talkback that allows users to control how they want to navigate through a screen. This was something I actually wasn't aware of previously when I started playing around with Talkback. But one thing you can do is that you can change how you navigate through a screen, and then you can say, I want to navigate through a screen by headings or paragraphs or other things. So if a user has this set to headings, they can move through a section content with a lot more ease. So let's take an example. So here we have a simple text composable, which is displaying the title of a section of our screen. It's likely that we'll have maybe multiple sections that are styled like this, but each section of our screen will have some form of title, and then maybe after this text, we'll have a bunch of other things that the user can navigate through and read, maybe some text, an image, and so on. If that was the case, the user would have to navigate through each of those items using Talkback. What we can actually do here is utilize the heading semantics. So for each of those titles on our screen, we can mark that text as a heading. And then if the user is navigating through a screen via headings, they can essentially skip all of the content that is between each heading and quickly move between different parts of the screen. For screens that are showing maybe articles or a lot of content, this can really help to improve the navigation through the stuff that we're composing. Cool. So yeah, when we're using headings, great to break up content and allow the user to navigate through sections easily. So it's important to be aware that with this available, it actually gives us the opportunity to think about how we're structuring our screens. Like I said, I had no idea this was a thing before, but now I know of it, you can start to think, how are we structuring our screens and how are we breaking things up into different sections and how can we make it easier to navigate around? So yeah, don't use headings for things that aren't headings, kind of goes without saying, but yeah, if it's not a heading, find another way to break the content up. And headings are also described, so they probably don't make too much sense for visual decorations unless they portray some kind of meaning. Cool, last one. So at this point, we've covered a lot of concepts around semantics and navigation. I want to finish up with one more thing, which is custom composables. So it's likely that in our projects, we're going to be creating custom layouts, canvas drawing, and so on. And in these cases, we will often have a blank slate when it comes to semantics. So we need to be even more aware of how our content is being described to users. So let's take the case of building our own checkmark component. We might have a row that shows an icon and text. So while styling of these depends on some flag, that allows the user to toggle things on and off. So if we're going to do things like this, we need to think about how these components are going to be portrayed by the accessibility services. So while for us, a user not interacting with Talkback would just click the item and probably not know any different, Talkback uses the semantics to provide more context here. So instead, we can use a toggleable modifier to build a custom component that represents its purpose. So previously, yeah, we were just using the clickable modifier, but now we're actually using something that was designed to make a composable toggleable. Now, when this is being interacted with by the accessibility services, TalkBack knows that we're using a toggleable component. So, while previously, yeah, this works and it allows the user to click the component on and off, the accessibility services will communicate that differently to the user. So we use the modifiers that are available to us and the things that operate in the way that are expected. We can help to, help TalkBack to work better. Another example of custom components might be scenarios where we're using the canvas. So in these cases, we also have kind of a blank slate. We're drawing custom composables on screen, just like we would do with the UI Toolkit canvas. So here, I'm just drawing a simple shape, which is a button, a custom button that is drawn on the canvas. And there's like a plus button, it's like an add to cart button. But because we're custom drawing, the accessibility services doesn't know this is a button because I'm drawing the button on the canvas. And we want to ensure that the user knows that this is a button. So what we can again do here is just like we would have done in the previous slides, is utilize the on-click labels and semantics just like you would do for other composables. Here I've defined the role as the button role. I've also provided the on-click label. So as you can see, if we're doing custom drawing and canvases, things aren't too different. We'll have a bit more of a blank slate, so we have to be sure to provide the information that the accessibility services need. Cool. So with all that in mind, we now have a good handful of knowledge around how to make our composables accessible. And this isn't an extensive collection, and I'm pretty sure there's more you could do here, but it's enough to help improve how our apps are experienced. As an engineer, I would highly encourage you to use TalkBack on your device. Again, I'm really disappointed the videos don't work because it's quite interesting to see how things work. So yeah, I'd really recommend turning it on your device and seeing how your apps work and maybe finding out where your apps fall short and even the apps you use fall short. It's a good learning experience and it's helpful to understand how TalkBack works and what you can do there. Cool, so further reading, there's obviously the Accessibility Code Lab from Google, have some accessibility articles on the Compose Academy blog, and there's also some great blog posts to read further about the things that I've talked about here. So yeah, I'll leave that slide up if you want to grab a photo. That's it from me. Yeah, again, apologies for the video. Yeah, I'll put these online so you can watch them, but yeah, hope that was helpful and happy to take any questions. Hey. So with, I don't know too much about the inner workings, but with Jetpack Compose, we have, about like how the UI hierarchy is structured. And then there's also like another tree in parallel to that has the semantic references. So we essentially have two trees. One is for drawing the UI, and another is describing the UI. It's kind of the same, but just a different purpose. Yeah, it's completely behind the scenes. Hey.
Oh, I don't have to shout. Can you hear me?
Yeah, that's great.
Thanks for that. So previously doing views with XML and everything, to try and get into a good habit of test-driven development, especially around accessibility, we've had the accessibility checks API available to us, and that's been extremely valuable in ensuring that we're not breaking things without having to do those manual checks. And obviously there's, in old ways of doing it, you have your accessibility node traversal and the accessibility service. How does that marry across to this new world way of doing it? There are two trees. Basically what I'm asking is, can we do TDD with Composable for accessibility?
Using the accessibility checks?
Ideally, or an equivalent.
Yeah. I don't know about the accessibility checks on, it's Espresso, isn't it, for Espresso?
Yeah.
Because you can use Espresso with Compose.
Okay.
Haven't done it, but you can, I think it works.
Yeah.
So I'd be interested to know, that could be worth checking if you can use those accessibility checks with Compose. I wouldn't see why not, but don't take my word for it.
Yeah, I guess I don't know enough about what's under the hood to be able
Yeah.
to say whether it's...
Yeah, 'cause I know, sorry.
Yeah.
Yeah, I know you can use espresso, but whether the accessibility services work or not, I'm not sure. But I would like to check that, because that would be interesting to know, because I think that will really help. And that would probably, if that's possible, that would probably help with the TDD side of things.
Yeah.
Yeah, sorry. Sorry, I
No,
can't
it's
do more
okay.
on that.
Where could I find out more about kind of that level of detail?
On the Compose testing guide, I think right at the bottom there's a section on espresso interop. Mm-hmm. So I think that would probably be a good place to start, because then it shows you how to use espresso with Compose, and then I guess that way you could be able to check if that works.
Cool, thank you.
I'd be interested to know if that does.
Yeah.
Cool. Can you hear me? Okay. My question is, earlier you mentioned about the content description and setting it to null. I mean, if we didn't want to focus the element, is that something we could do as well? So obviously, is accessibility important? No. Is that recommended?
If you didn't want it focused?
Yeah.
Yeah. You can do that, yeah.
If we're not going to read it out anyway, it would just make sense just to skip it in the order.
Yeah.
Okay, cool. Thank you.
Cool. That's it, I guess. Oh, was there someone else? Oh, yeah, there was. Jump the gun there.